complexity then they write it failed. So if you want 4 partitions, okay. Define structure of a node. So one is data partition and another one is left pointer and right pointer. Okay, struct node star left star right, and height we want to store now. So for that height of a node, so simply you can take height. After structure we have to put semicolon. So semicolon. First we will write height function. So how to find out height? So for height function I am taking the function name as height. So height of a node we want to calculate. So that's why struct node star some n I have taken. Okay. Then if that node is null, if that node is null, then there is no height of that node. Okay, so just return 0. Otherwise, what we have to do is, whatever the data present in that height partition, that height we have to return. That means, so here, whatever the data present in this, that we have to return. Okay, that will be returned. That we are doing in height function. Now, we have to find out maximum heights. So why? Because, so what is the left subtree height and what is the right subtree height, that we have to do now. So here this is tree if you have considered, then we have to compare. So which one is maximum, whether left subtree height or right subtree height. So for that we are taking another method, that is finding maximum of 2 elements. So maximum of 2 elements, some integer a comma integer b, then return. You can use a ternary operator for simplicity purpose. If a greater than b, I think you remember that one, a greater than b, then a is maximum, otherwise b is maximum. So that is maximum of 2 numbers. Then we have to find out balance factor now. So now balance factor is a heights difference between left and right. Okay, so find out balance factors. So it has to return a value. Why? Because balance factor is an integer. So heights a difference between left and right. That's why here it has to return integer. So balance factor of that particular node. So struct node star some node. Okay. So now suppose that node is null. If that node is null, then what is the balance factor? As it has to return integer, so return 0. Suppose node is existing, then how to find out balance factor? So balance factor we have to return like height difference between height method. What is the height method we have taken? So capital H. So I am taking small h. Okay. If node is, we have to find out the balance factor, which is heights difference between left and right. So call the methods height of the nodes left minus height of height of n of left, then height of n of right. So heights of left subtree minus heights of right subtree is nothing but a balance factor. Okay. So now close this one. So that is balance factor calculation. Okay. After balance factor, so what we will do? Simply we can write rotations, we can write easily. So now rotations, or directly you can write insert method, no problem. In insert method we will call all these methods now. Okay, so I'm writing first rotations, struct node star. So first I'm writing single left rotation of struct node star some y, or struct node star some a, whatever it is. Okay, or you can take PTR, which is local, na? You can take PTR also, no problem, right? So now declare other variables. If you observe, take one example here. For example, see here 10, 7. Already some element is there here. Here some 20, and here some element is there. 7's greater means you may get 9. Okay. For example, here there is no element. Yeah. So now here we have inserted like 5. This is the new element we have inserted. Okay. So then what we have to apply? Single left rotation we are applying. See, you are rotating towards right side. But now what I am assuming is, so the arrow mark is from left to right. I am taking single left. Some other textbooks or some others may assume this as a single right rotation. This is my point of view. I am taking this as a single left rotation. Okay. Here what is going to happen? Here the property is failed. PTR. Then 7 will become root node. 10 will become 7's right shell, where you are getting pointers modification. So actually before rotation 10's left is 7. But after rotation 7's right is becoming 10. Okay, 7's left as it is. PTR of left. Then what is here y? T2. T2 is x right. So same declare that struct node star T2 equal to x right, or here excuse me. Okay, x right. So assume this as if you assume this as y, you can take this as easy instead of writing that one. Here you can write y. Now we have to change the links. Now we are changing the links. X of, already here I have mentioned, x of right equal to PTR, x of right equal to PTR, then y's left equal to T2, and then we have to update the heights. So y height, what we have considered here, height HT. So y's height, we have to update the heights equal to maximum of height of left subtree and height of right subtree, whichever is the maximum. For that, plus 1. Similarly, y height you are getting modified, na? Okay, so here this is y. Y height here it is modifying. Then x height also we are getting modified. So that's why update that one. X of height equal to the same thing. Instead of y, simply we will write x. See the parenthesis. Parenthesis is fine. So here x we are finding, and here x height. Okay. So finally, which is becoming root node? Finally, x is becoming root node. So finally, return x. Okay. In the same manner, now save. In the same manner, single right rotation. Okay, so now single right rotation. For single right rotation also the same thing. Struct node star, method name is single underscore right of struct node star. For this I am taking reverse x. Now the same thing y t2 we have to declare now. So now struct node star y equal to x right. Okay, and then t2 struct node star t2 equal to y's same like here. Now similar to single left rotation, here single right 20 30 40 for example. Here the property is failed. Assume that as x. Now assume this as y. Okay, now after rotation you will get like this. 30 is becoming root node, which is y. 30 is becoming left child for y, x. And of height of left subtree, comma height of x right subtree, and then plus 1. Okay, so now then x of height we have updated now, similar to x, y height equal to height of y's left, height of y's right. So this parenthesis is closed here, this parenthesis is closed here, this parenthesis here. Okay, so now close this one. So that is single right rotation. So now after single left and after single right rotation, now we can call insert method. Okay, so now coming to insert method. Struct node star insert of struct node star ptr comma data. Which element you want to insert? Instead of data, here you can take it as some element. Okay, so now we are going to insert. This is similar to binary search tree, and then we will check balance factors. Okay, if ptr equal to, if there is no node, then what shall we do? Save. Allocate memory for that node. Struct node star save it. So struct node star. So here we are allocating memory for node. Struct node ptr equal to typecasting struct node star dynamic memory allocation malloc method malloc size of struct node semicolon. Now we have to insert the data now. Data is ptr of data equal to element, then ptr of left equal to ptr of right equal to, as they are leaf nodes, then left and right pointers and null pointers. Okay, and then we have to write the height of the node. So ptr of height equal to 1, and then return ptr if the node is not present. Okay. If node is present, how we have to insert based on less or greater. If it is less, okay, if it is less, then insert on left side. So ptr of left equal to insert of ptr of left comma ele. If it is not less, it may be greater. So if element is greater than ptr of right, then this is similar to binary search tree program. Okay, in binary search tree program also we have done like this. You please watch my binary search tree insertion program. Okay, so ptr of right equal to insert of ptr of right comma element. Okay, after that, after insertion we have to update the height of that node. Okay, so we are finding height of that node, ptr node na. The same thing here, whatever here we have written, the same thing here we have mentioned y, here we will mention ptr, simple. ptr. So after insertion, that node height will be updated. ptr of height we have updated. Now after calculating height of that new node, we have to find out balance factors. If balance factors are not satisfying the property of an AVL tree, then we have to apply rotations. Okay, so first find out balance factors. So balance factor integer, like BF I am writing balance factor equal to, here balance factor function we have considered this one, balance factor of. So we will calculate that balance factor of which node, that a new node. Okay, ptr. Now after getting balance factors, check the conditions. If balance factor is greater than 1 and element is less than ptr's left of data, okay, then which rotation we have to apply? Single left rotation, single left of ptr. Okay.
Need to run Windows on your Mac? Parallels Desktop.
तो कैसे हैं आप लोग? क्या करूंगा, रिटर्न कर दूंगा इसकी हाइट, ठीक है। इफ आई एम नॉट रॉन्ग, मैंने सही किया है, हाइट ओके। मैंने कुछ इस तरह से लिखा यहाँ पर, लेफ्ट रोटेट, सॉरी मुझे राइट रोटेट इसको लिखना चाहिए था। राइट रोटेट आई की हाइट है वो क्या होगी, यहाँ पर क्या होगी, इस नोड का बैलेंस फैक्टर ना नोड, ठीक है। एंड वेरी सिमिलर केस, फाइनली जो हमारा ट्री होगा उसके अंदर सारे रोटेशंस हो चुके होंगे, ठीक है। तो फाइनली हमें क्या रिटर्न करना है, हमें फाइनली रिटर्न करना है नोड को, ठीक है, क्योंकि नोड को हमने कभी चेंज किया ही नहीं था, ठीक है। तो हम फाइनली नोड को जो है वो रिटर्न, ठीक है। मैं इसको विजुलाइज करूंगा तो 45 में 4 इंसर्ट करेंगे तो लेफ्ट में इंसर्ट हो जाएगा, फिर 5 करेंगे तो उसके राइट में इंसर्ट हो जाएगा, फिर 8 करेंगे तो हमारा कहाँ पर इंसर्ट होगा, 5 के 45 से छोटा 4 से बड़ा 4 के राइट में इंसर्ट हो जाएगा, 9 करेंगे तो वो 8 के राइट में इंसर्ट हो जाएगा, ठीक है। तो कुछ इस तरह का ट्री हमारा बनेगा। तो उसके बाद जब बैलेंसिंग वगैरह होगी तो मैं काम करता हूँ, जल्दी से 1 2 3 4 लिख देता हूँ, ठीक है। अगर मैं 1 2 3 4 करूँ तो आइडियली ये सब के सब एक डायरेक्शन में टर्न कर रहे हैं। और अब मेरा रेवियल रोटेशन डॉट सी जो है वो मुझे ये ऑर्डर दे देगा। और मैंने खुद से एक ट्री ड्रॉ किया है, यहाँ पर मैं आपको कैमरे में दिखाता हूँ। अगर आपको, हम लोगों ने एवीएल ट्री अच्छे से समझ लिया, आप लोगों को समझ में आ गया जितने भी लोगों ने एवीएल ट्री का वीडियो, लेफ्ट रोटेट, राइट रोटेट, सिर्फ मुझे रन नहीं करना है, मुझे रिटर्न करना है, क्योंकि ये फंक्शंस नोड्स को रिटर्न कर रहे हैं। और अब मेरा रेवियन रोटेशन डॉट सी जो है वो मुझे ये ऑर्डर दे देगा। और मैंने खुद से एक ट्री ड्रॉ किया है, यहाँ पर मैं आपको कैमरे में दिखाता हूँ, अगर आपको दिखेगा। एंड आई डोंट नो वेदर दिस इज द बेस्ट वे टू शो द ट्री, बट मैंने ये ट्री यहाँ पर ड्रॉ किया है एक छोटे से पेपर पर जो कि मुझे अवेलेबल था। और मैं आप लोगों को बता सकता हूँ कि ये जो इसका प्री ऑर्डर ट्रैवर्सल है वो बिल्कुल ठीक से आया है। तो इसका प्री ऑर्डर
The same thing. Here we have mentioned y. Here we will mention ptr. Simple. Complexity and they write failed. So if you want